Welcome, Algebra 2. Here we are with composite function notes. Beginning of Unit 2, Lesson 1. A little short unit here on inverses, and we're going to get it started with composite functions. Composite functions just basically means you're using the result from one function as the input right away in another function. So I like to think of these as machines, like an assembly line. Okay, you're dropping x into the f of x machine and it does its thing. And then whatever comes out of the f of x machine immediately falls right into the g of x machine. Doot, and out comes the packaged product ready to go. So you put like 3 in here and it does its thing, and 3 comes out as like 12. And then you put that 12 into this equation, and it comes out with your final answer of like 8. Okay? If we have time, I always like to show the Sneetches on the Beaches, the Dr. Seuss video. Getting those stars on and off their belly, kind of like function machines. Okay? So if there's time in class, we'll watch that. And we got some funny notation. We have F, and it looks like an O, or like a degree sign. Like if you had like 35 degrees, but it's like right there in the middle, just floating in the middle. But it's the same size as like a degree sign about. F of g of x, this is f of g of x. F of g of x, or sometimes you'll see it with parentheses, f parenthesis g parenthesis x, double closed. We're going to go in reverse order. You're going to take the x, you're going to put it into the g equation, take that answer and put it into f. So you read it left to right, but you do it right to left. Okay, we're going to start you off with numbers first, and then we're going to progress on to letters only. Okay, so f of g of 2, or you could also write it f parenthesis g parenthesis 2. It's the same thing, f of g of 2. When f of x equals 2x plus 1, and g of x equals x plus 7. So we're going to go in reverse order. Okay, we're going to take that 2, we're going to put it in the g equation. Okay, 2 plus 7 equals 9, right? Put 2 in, 2 plus 7 equals 9. Then we're going to take that 9 answer and whoop, put it right in for f right away. F of 9 equals, okay, 2 times 9 plus 1, 18 plus 1, 19. Final answer, 19. Okay? Let's see if you can go the other way on your own. Start with 2 and put it in the f equation first. Get that answer and put that answer in the g equation. Okay, go ahead and push pause and try that one on your own. Okay, welcome back. If we did f of 2, we're going to do 2 times 2 plus 1. That's going to give me 4 plus 1, 5. Then I'm going to put that 5 right into the g equation. And g of 5 is 5 plus 7 for a 12. Hopefully we got 12. All right. Let's do some more problems on your own. This time we're stepping it up. We got a little bit tougher equations. Our f equation, our f function is 2 times x plus 3, and our g equation is x squared minus 7. So we've got f of g of 3, and then we have it written this way, g of f of 3. Okay, either way, we're talking about doing the same thing, composite functions, and we're going to do it reverse order, right? This one, the 3 is going to go into the g equation, and that answer is going to go into f. This way, the 3 goes into the f first, and then goes into g. All right, take a minute to give those two a shot. Go ahead and push pause on the video. Okay, let's see how you did. We're doing 3 into the g equation first. The g equation is x squared minus 7. So we're going to do 3 squared minus 7. We got 9 minus 7 for 2. We're going to put 2 into the f equation. 2 times 2 plus 3. Okay, that's going to be 4 plus 3, 7. Now let's try it the other way. we're going to go with the f equation first. 3 into the f equation first. We got 2 times 3 plus 3. 6 plus 3 equals 9. And then we take that 9 answer and whoop, put it right back into the g equation. So we're going to do 9 squared minus 7. 81 minus 7 should be 74. Alright, hopefully you're doing good with those. Now we're going to step it up. No more numbers. Well, I guess we will have some numbers, won't we? But we got letters in there too. Okay? Let's see how this works. It's going to be basically the same thing, but now you're going to take the whole group and put it in. Okay? F of g of x. So when you're just doing f of g of x, it's actually a little bit easier on the first step, because if I just put x into the g equation, it stays the same. So really what you're going to do is you're going to take the whole g equation and put it into f. Right there. Okay? So we're going to take the whole g equation and put it in for the x spot. X squared minus 5 goes into the x spot. Just like if you would have had a number, right? If this would have came out as like 20, you would have put 20 there. G of x, I put x in, it doesn't change it. X squared is x squared minus 5. Can't do anything. It's x squared minus 5. We're going to take that whole group and put it right there. Plus 3. Okay? X squared minus 5 plus 3. Minus 5 plus 3 is going to be minus 2. And that's that one. Not too bad. Going this way, it's a little bit more fun. Well, I think it's fun. Okay, again, f of x. If you put x just in there for x, it's not going to change. So really what we're doing is we're taking the whole function and putting it into g. So I'm going to take this whole thing, I'm going to put it in for that x spot. X plus 3 squared. Putting that whole x plus 3 in there, that whole thing gets squared, minus 5. Now this is always tricky every year, whether it's Algebra 1, Algebra 2, pre-calc. Every year this is tricky for everybody. Parentheses squared. It's not x squared plus 9. Okay? Parentheses squared means you have two of these times each other. You have an x plus 3 times an x plus 3. So my best advice to you is, if you struggle with this, is to write it down twice and FOIL it out. And we'll have x squared plus 3x plus 3x plus 9. X squared plus 6x plus 9. And don't forget about your minus 5. 9 minus 5 is going to be a 4. Okay? That one's a little trickier. Now there is a shortcut here. Okay? And yes, you do end up having x squared, and you do end up having 3 squared 9. But you're missing the middle stuff if you just go x squared 9. The other shortcut to get the middle part is you multiply these two things together and double it. So x times 3 would be 3x. Double it, 6x goes in the middle. That's the shortcut. Square the front one, square the back one, multiply these two things together, double it, and put it in the middle. Okay, if it would have been a minus 3, then we have a minus 6x in the middle. Alright, your turn. Ooh, we got 2x spots over here. Be careful. Go ahead and push pause and give that your best shot. Alright, welcome back. Let's see how we're doing. F of g of x. Again, if we're just putting x in there, it's not going to change it, and you're going to end up taking the whole thing and putting that whole g equation into the f equation. So we're taking this whole big group and plugging it in right there where the x is. So we're going to have x squared plus 3x minus 1, all going in there, plus 2. X squared plus 3x minus 1 plus 2. The only thing we can combine is the minus 1 plus 2, and we'll have x squared plus 3x plus 1. Okay? Now the other way is a little bit trickier because we're taking that f of x and we're putting it into the g equation. And in the g equation there's two x spots. Okay? There's two x spots. So this is going to go in there and in there. So we're going to have x plus 2 squared plus 3 times x plus 2, and then the minus 1. So that is a little bit trickier. Okay, if you need to FOIL this out, go ahead and write it down twice and FOIL it out. Otherwise, let's try the shortcut. Square the first one, x squared. Square the second one, plus 4. Multiply them together, 2x, and double it, plus 4x in the middle. Okay, 3 times x, 3 times 2, minus 1. Alright, let's combine some like terms. Okay, there's no other x squareds. We have a plus 4x and a plus 3x for plus 7x. And then we'll have plus 4, plus 6, that's plus 10. Minus 1 is a plus 9. Alright, folks, this is a tricky one, so take your time with it. Alright, this is a tricky one, so take your time with it. It's a very important lesson, though, because it sets the groundwork for how we're going to show or prove inverses later on. Alright, and if you find yourself with some extra time and want to take a trip down memory lane, go ahead and go through YouTube and look for those Sneetches on the Beaches by Dr. Seuss. Alright, kids, thanks for watching, and we'll see you next time.